Hello dear friends, welcome to another video of the Never Do Through the GUI What You Can Do Through the GUI channel. I am Vangelis Prokopiou and you are watching Rust Mutex vs C++ Mutex feedback to feedback. Now, what I mean with feedback to feedback is that I want to address a comment that I received in this video, which I created yesterday, and I will have a link to this video in case you haven't checked it out. I received this comment by Pedantic79, which I think is very useful and constructive, and I wanted to address it. Let me zoom out a little bit. I wanted to address it in order to both give a shout out to Pedantic79 and to clear up any misunderstandings that may have occurred through this video. So, what the feedback of Pedantic79 is first that he says that there is a more idiomatic way of using a mutex lock and unlock. Okay, this is of secondary importance. The main thing that I am interested in is I want to zoom in order for you to be able to see the comment. Give me a moment, please. Here it is. Okay. He writes, wrong. He means about the behavior of the program, that it overrides our map. What happens is not a difference in C++ and Rust. A version of this program in Rust will still exhibit the same behavior. The difference is that your C++ version is written incorrectly for a concurrent program. In any programming language, you must employ some synchronization method to ensure two threads are not modifying the same area in memory. The difference is that Rust enforces that and would force you to lock access to the map. It does not fix the algorithm, which is the cause of the different behavior. Here is your program written in Rust, which I copied. I have it here. And we will look into it, of course. And thank you very much for going into the trouble to create this program, even though it was a small one. Try running it a few times and see what happens. The only difference between this version and the C++ version is that Rust forces us to lock the mutex. C++ does not, but that is considered incorrect and bad programming. So let's see the program. Let's see the program in Rust. Here is the program. It's identical to the program we created in C++. You can check the previous video for that version. This is the program, so let's try running it here. And if we say cargo run, we are in the C++ program. We want the Rust program. So if we say cargo run, the program runs, so we can just run the binary. And we can clear the screen. Let's do it again. As you can see, indeed, we have the same behavior. We have one result here. We have no results here. We have one result here. One result. No result. Two results. So, as Pedantic79 says, we have the exact same behavior between the two programs. This is the C++ program. Let's run this again. Make build, and what do we want? We want the mutex cpp, and we want to clear our screen. we have 2 results, no results, 1 result. So as you can see, we have the same exact behavior between the 2 languages. This is correct. This is a nice observation by Pedantic, but my feedback is that, as I said in the previous video, this example I provided was a contrived example to show how you can mess up your program in C++, because C++ does not enforce you to acquire access to the data through the mutex, just like Pedantic 79 says here. No, we don't want to go there. We want our comment. We want our comment. Where is the comment? Here it is. Sorry for that. So, Rust forces us to lock the mutex. That was the whole point of the previous video. I agree completely with Pedantic 79. As I said, it was a contrived example to show what can happen to our program. You can have the same behavior in Rust, of course, if you modify your data from within another thread. But the profound difference is this one. Rust forces us to lock the mutex. So if we mess up our data, we are 100% responsible for this messing up, because Rust provides an extra layer of protection compared to C++. And of course, it is incorrect to create such concurrent or multi-threaded programs. Here it is again. The difference is that Rust enforces us to get an exclusive locked access to the map. This is what I wanted to stress. If in any case I got misunderstood and said that messing up a multi-threaded program in Rust is not possible, of course it is possible. I did not mean something like that. I will place these two side by side and to show you the difference in action. So the difference is here. This is the main difference. We got to lock the mutex in order to acquire access to the data. Just like, not just like, whereas in C++, the mutex is a different entity. I know I am repeating some stuff compared to the previous video. Of course, if you don't want to see this video, you cannot see this video. You can stop watching it. I hope that you live in a free country and have this at your disposal, have the ability to choose what you see, what you don't see, what you read, what you don't read, because this kind of feedback by some guys is just, I don't know how to describe it. Anyway, let's get on for the guys that want to watch and and take what they have to take from this video. Here in C++, we lock the mutex, a different entity. We do our stuff and we unlock. With a more idiomatic version, we would not have to unlock. This would become obsolete when the scope, depending on the scope of the execution. Here we get access to our data through the mutex. We have to explicitly lock the mutex to acquire access to the data. And now the point here in the lambda thread, this is the lambda thread running here. And the great difference is that again here we get an exclusive access to our data through the mutex. So the point that I'm stressing is that even though we can mess up our program in Rust 2, a multi-threaded program, we have to be very explicit about it, and it is 100% our fault. Because when we write this program and in Rust we acquire access to this data structure in a thread, then it's a bell that has to ring in our head and say that I have to check if what I'm doing here may affect the program since it is multi-threaded. Whereas in C++, as you can see here, if we wrote this code in a different file, in a different context, nothing may ring a bell in our head that we may have to double check about this data structure, if it is used anywhere, if not, and how we should go dealing about this thing. Of course, somebody may say that since you are already working with threads, you have to be careful about it, etc., etc., etc. But I still come back to the point that I was stressing, that the Rust implementation of the mutex is a better implementation than the C++ implementation. That's the point that I'm trying to get across. So, indeed, Rust adds an extra layer of protection, since the data that we acquire must go through the mutex through an explicit call to the mutex. This is all I'm trying to say. I hope I'm quite clear. Again, I want to give a shout out to Pedantic for his feedback. I really appreciate it, and I just wanted to build upon this feedback and stress this point one more time. This is all that I wanted to share with you. If you enjoyed this video, you can hit the like button and you can share your thoughts on it in the comments. Moreover, if you like the content of this channel, you can subscribe by clicking the penguin that you see on your screen. Thank you for watching and have a great day.